So I think today is going to be a bit of a crash course going into LLMs, what large language models would mean in terms of security impact. And I'll try to condense a few topics into these next 30 minutes for us. So I do a lot of work around Node.js, JavaScript, and that ecosystem around security. I do security research. I'm a developer advocate at Sneak. So a large aspect of my daily work is not just coding and writing vulnerable demos and security research, but actually using AI and MCPs and all these new protocols and seeing what they would actually mean for developers day to day in terms of security risks. And I'll try to introduce some of that to you here. So some of you might be triggered by this, but I see a lot of young faces here. So some of you have no idea what this is either. This is how we used to write code back in the day. This is decades ago. And I'll start like a quick journey, just like get us into the mindset of like why AI is here so impactful for security. So we started off with a few decades ago, just writing code. And then we moved on to things like, well, maybe I'll just copy code from somewhere else. Like there was a website that was very popular called Stack Overflow. Maybe you know of it. Maybe you copied some code. Maybe some of the code you copied from there actually had vulnerabilities in it. Funny story. But then we moved on and, for example, for NPM and not C++, which was like still a bit stuck in the day, have package managers. So now we can not just copy code, we can actually manage dependencies. Super high tech, amazing. And then we moved on and we have this capability about in 2021, so about like 4 years ago, Copilot introduced this idea of ghost text and completion of code. So now when you just click the tab key, you wouldn't get the regular IntelliSense autocomplete of like the function name and its arguments, but rather it would be much more code completion. It would be full functions, sometimes multiple functions around the code, because Copilot, when it introduced a few years back, before ChatGPT, had this amazing magical effect that you would now understand the code base for you. So your tab to complete was not just IntelliSense. That was magical back then. And yes, vibe coding. AI conference without mentioning vibe coding seems like a miss. So I'll chat about it a bit here. So we kind of like even transitioned a bit further than vibe coding, right? Like we call it maybe contextual engineering and maybe viable coding. But vibe coding as an essence of prompting your way into code is something that is still core to how we use AI today. So here's one person's aspect of what vibe coding means. And I look at it and I think, okay, yeah, that's a lot of tech that's probably piling up when you vibe code and there's like a lot of code getting generated, maybe hundreds or thousands of lines of code. And I look at it from a different aspect. Like I put my lenses of a security-aware person and I see security that as well, right? We don't always go there directly, but I do that jump and I would like you to do that jump as well. And throughout this talk, I'll show you what it means. But even before we jump into my demos, I will share a few of those with you here. Like people complaining on X, like, hey, you know, I just vibe coded an app and someone realized that all of the waitlist is just saved on the front end. So everyone registered are, you know, out there for everyone else to grab, so privacy issues. And then someone blaming Cursor in another different post that, well, the subscribe button just didn't work. No one tested it, there's no tests. So basically they lost revenue because all of the people signing up did not really have to pay any money. So you could blame Cursor if you wanted to, not really Cursor's job. But if you look back into what this means, if you can like try to wrap up the common denominator here around code, what does it actually mean? It means that code is the thing that flows with us. It's always been there, right? And on this track, a few hours earlier, Engin was here, was talking about code in terms of platform engineering, IAC, like it really is the thing that kind of like flows and is part of us. And not just part of us, but really is the part that attackers and adversarial actors actually target. So if you look at it from the lens of what happened before, decades ago, even today, but decades ago too, attackers would go and try to find and infiltrate to vulnerabilities that exist in code that we were writing, or in code of dependencies that someone else was writing but we used. Not really that different today, right? We use the agent to create code. That's still code. From the attacker's perspective, they will still go and look for vulnerabilities. There are some changes in what attackers will try to exfiltrate and breach in terms of security here, but the fundamental concept of just generating more code using LLMs stays the same. More code, potentially more bugs, potentially more vulnerabilities. So that's going to be one aspect that we'll deep dive into today. So that's good to keep in mind. The other one is LLM in code. So a lot of us are actually using large language models to just power applications, right? Power our applications in a way that they become agentic. So we don't just use the AI as a coding assistant or a coding agent or a background coding agent or something like that. We actually integrate with the model. So user input goes through our own business logic into the model and then back into the app in some way. And that also creates a vulnerability, an attack surface that we have to be aware of. So I'm going to group those two things into these naming conventions. We're going to talk about a deep dive of I will show you actual real world examples of how both security issues exist in these different, but still both of those worlds. We'll start with AI-assisted coding, and we'll talk about vulnerable code itself, how that creates an attack surface, how that is also exploited, and also what we can do to find and protect against it. And also we'll talk about prompt injection on the other side of it for our AI apps. But I will not show you examples of prompt injection to just exfiltrate data in terms of getting the chatbot to buy a car or some examples that you've seen online. I want to show you how prompt injection translates into actual business issues. Okay, so we'll go through that. And I imagine that you're now kind of like wondering, well, does AI actually generate vulnerable code? Because we all use like the latest model, right? Opus goes out, we use it. GPT goes out, we use it. 5, 5.1, 5.2. They seem to always be getting better and better. Do they? So here's I'm reading a lot of academic research and just research in general. There's a lot of that being done today, unrelated even to just benchmark from the top tier model companies. You can just find so many of this going around. This is a historic artifact from way back then in February 2025. So not really that old, but still, like they benchmarked in this paper both Python and JavaScript. I focused on the JavaScript part as I'm coming from that ecosystem, but the results are pretty much the same. 1 in every 4 lines of code that the model generated for JavaScript was found to be vulnerable. And actually, this is quite interesting because it's not just vulnerable. The variety of vulnerabilities that the code actually had were very different. About 40 different types of classes of vulnerabilities. If you try to come up with the examples of different classes of vulnerabilities, you might think of XSS injections and broken access control and code injections and CSRF, and maybe you can count 4 or 5 more. Maybe prototype pollution if you're coming from JavaScript. If you're coming from Java, you'll think about serialization and deserialization issues. But 40 of them, can you come up with 40 of them? Like one of them is unrequired or unnecessary or just broken random cryptographic keys. It's not something we'll think about it, but the code that gets generated by AI isn't always top tier on very performant code and very accessible code and very secure code, right? It's just code that it learned from all of us writing code from Stack Overflow, as an example. And so it seems so obvious, right? Liran, just tell the AI to fix all the vulnerabilities, just prompt it. It's like prompt away, just one prompt away from fixing everything. It's so logical, it's brilliant. They thought so too in the research. That's what they did. They were like, yeah, you found a bunch of issues. Go ahead, fix them. So easy. So if you try that, and they benchmarked this as well as the next chapter, they found out that if you do not use a security analysis tool to feed the model with more data, to give it more enrichment of metadata, you would still only get stuck at like 20% of what it will actually fix. So if you use the model and you trust it to generate code, and you also trust it to fix your code, and you push that app to production, you're basically having an 80% attack surface of vulnerabilities that you might not even know that are not actually secured, are not actually fixed. Nothing was found by the model. More of that, I found this on GitHub Copilot's support page. So if you think everyone are out to protect you, it's not really the matter. You probably have seen that, like Google's own beta all the time for models and apps. It's pretty common with other tools like you would see on chatgpt.com, for example, this asterisk below that says, do not really trust the model with everything. We don't guarantee it. And Copilot says the same thing. It doesn't guarantee that the code that gets generated by Copilot is actually secure. Here's another attempt that I wanted to share with you. This is an interesting, also like a very, very, very old, like ancient research from like way back March 2025. Hilarious. They try to see and benchmark how well do coding agents and models actually fix issues, okay? Not just find them, fix issues. So to the left, you can see Python code. I'm sorry for the Python code here. But it's vulnerable to patch reversal. And the model was told to fix it. So there we go, fixed code to the right. Great job. Great job by the model. I mean, it's secure, just not really functional, so there's that. So let's see more of like AI-assisted coding beyond the benchmark, beyond all the research. I went into ChatGPT and I was like, okay, let's build an upload post route in my Fastify application. Let's say I'm an engineer who doesn't really understand how to handle files. So maybe there's like a lot of stuff related to it, like multi-part file data uploads, binary versus not binary, whatever. Maybe I'm not really sure which dependencies I should add as middlewares to a Fastify. It's a web framework for Node.js. So the model helps me out. And I've got all of this code created, which looks pretty great. I mean, if you look at it, it's actually functional to a point of copy and paste. So I will use that and literally copy and paste it to my code. And that might seem, actually, even today, right, that might seem not really advanced. It's like not, like coding agents are more inherent, but very highly regulated ecosystems and places at work, you have to go out and sometimes not install those things in. So I gave you a bunch of seconds before, as I was talking before this was running, but if you haven't caught the fact that there was an issue there was a patch reversal vulnerability there that is now highlighted as a static linter. And my point is, even ChatGPT at its very recent and newer models, which even today hard to keep up with, but even then, if you were to keep up with it, it still generates vulnerabilities in the code. And if you didn't have something that would actually find and track all those vulnerabilities, when you paste them, when the agent generates them, you would potentially not even know to try and recognize them. I tried a different approach, which is like I try to steer it towards, hey, create a safe and secure code, like in case you think this will actually help you out. I'll give you a second, but you know what's coming, and I hope you learned from the patch reversal before. There's file handling here, and something is being read from the disk, which is potentially a patch reversal vulnerability. So good to be aware of that and have tools that help you recognize those kind of like bad and insecure code patterns from agents, and basically from humans too, but this is an AI conference, so we'll talk about it. And so another demo is, I remember when Copilot went out, this is like, again, back 2021, a lot of the pressure and the requirement was, we want the code to be the same, that's generated, the same as the way that our team works, right? Like you want the same coding conventions. Things like, spaces versus tabs and stuff like that, which can, kill a team. So you kind of like want the same code. So now agents will study your code and generate code in accordance to your coding standards. Makes a lot of sense, but this Java code base has an old repository pattern that uses concatenation for SQLs from user input. So now there's an SQL injection in some maybe even outdated, maybe even not used code path. But when you go ahead and try to generate more code like it, you get the same stuff. Okay, so existing issues in repositories might be amplified, like vulnerabilities, because the coding agents try to just follow the exact same patterns. So if you have a really bad pattern in your code, whether you know about it or not, it will only get amplified, more and more and more of it. Okay, so this is why you also have to understand that existing code bases and legacy code bases have this kind of potential tech debt or security debt when you just throw an agent on them. And I guess my last demo for this on coding agents is gonna be how well coding agents really are when they're like state of the art, when they just get released. So again, this seems like ages ago, but Claude 3.7 wasn't that long ago. In these times of AI, it seems like forever, but still, what we are doing is more like trying to benchmark models. So we would go and we have this exact same prompt where we tell the model, hey, create a node to do application, and we try to stress the model to actually get it to create secure code. And we do the exact same prompt over the last, I think, couple of years across different AI tools and also different models. And we compare and see how they do. So we just let them go and then we scan them. So here is that practice. That's my buddy Brian. You can see he's choosing, this is like a day or something after 3.7 landed, right? And people said, yeah, this is like the best coding model ever, right? Everyone were anticipating this after the Claude code, or sorry, even before, I think, Claude well-executed models. And he's like stressing the model, you have to generate security issues. If it has any security issues, I'll be fired, and so on and so on. And Claude just goes and generates all of that code, which is, looks pretty well. So if you look at the code, and you actually can go after this talk, open up GitHub and find, you can see to the left with the directories, we actually benchmark and try this on a bunch of other models and apps as well. And when you look at what Claude 3.7 generated, at first glance, it looks pretty well. Like for telling it, just create secure code. This is, months back. This is like pretty cool. It has, request size, rate limiting, no SQL injection prevention, XSS, has all the right middleware. Maybe you even know some of this, maybe you even don't know some of this existed. So you read this and it looks pretty great. And I went line by line and then I find, schema validation. That's great. There's now a schema validation for nodes, which makes sense. For this, there's a very common and popular NoSQL injection payload and a really bad and insecure pattern that you see a lot with Node and MongoDB type of like technology stacks together. Built as an app. And so again, you could see that there is a really good pattern that is being used here that is not vulnerable to NoSQL injection. So that's pretty cool. This is also pretty cool, I guess. There's database level schema validation that uses regex. Database level schema validation that uses regex. Database schema validation that uses regular expression to validate the data. Now, maybe that doesn't ring a bell for you, but for me, as someone who is very security-minded and aware, regular expressions for Node.js and some other languages and runtimes pose a really bad issue. There is a vulnerability called regular expression denial of service. Basically, when a Node.js application spins up, there's one main thread for all the JavaScript resolution to go on. And everything else is like blocking I/O. So when you tell in the code to the language, hey, I just need to resolve this regular expression to match a string, what happens is not a blocking I/O scenario. What happens is actually CPU-intensive work. Right? This is like basic engineering stuff from like the way that we used to code ourselves, not prompting the agents these days. So when your regular expression is written in a bad way, in a flawed way, input from users will actually get interpreted in some way that can cause infinite amount of time for the regular expression to return. Okay, that means the entire Node.js main loop would just spin off doing that, computing the regex, not delivering any other request to the app. So if you've successfully now created a payload that the application itself faces a denial of service. So when I see this, my mind goes like, wow, this is like really bad. This is, to remind you, Claude generated a regex to validate the database email address. And Claude generated this specific one that is flawed. How is that flawed? I will show you. Maybe not everyone is here or versed on regular expressions. So here's the regular expression from the image before. Maybe you see it, maybe you don't, but basically step one is if your app uses regexes in some way, by the way, not just for email validation. In this case, this was the scenario. And you push in this post endpoint, which is, by the way, like very severe case in this case, because that's not even like an admin level route or authenticated. This is unauthenticated open route that uses this flawed regex validation. And all I have to do is come up with this kind of string. And if you send that, here's my debug session from that repository that all of you can easily reproduce at home when you go back. You can see on the tab the amount of milliseconds that took Node to process that request. That goes to about 2.5 minutes of the node not processing anything else except this request. For denial of service in the service of Claude 3.7. Now, all of those were examples of, as we said, right, like AI-assisted coding. There's a whole lot of issues around that, and I hope you like review the code well. You use security tools to actually vet the code and not tell the model, review the code yourself or something like that. Remember, models are non-deterministic by nature. It's not something we want to fight against, but rather something we want to fight around and across. So I will now shift kind of like to different kind of challenges, and that's AI-powered applications. So what if we were able to now, in our code, when we use AI and integrate with LLMs in different ways, we're able to like steer the model to do different things than what intended. And that's basically exploiting this fact of like being reliant on the models and kind of like trusting them way too much. So this reference goes back to 2015 when Google back then had this idea of like adversarial attacks. This is basically a prompt injection, but in a visual way. So the way that you'd think about it is the image to the left has a panda, obviously, like it looks like a panda for us. Apparently, this is also a panda, but not the way that machine learning engines will actually recognize them, because in this experiment, what they showed was like, what if we were able to create another layer of a disturbance pattern that actually has pixels that flip the neurons in such a way that when they are applied to the image, the machine learning algorithm behind the scenes that actually reads the image back would represent it in a different way, and that's why you get a different kind of a different kind of classification, a label for that image if you just show this to a machine. So I was thinking, okay, let's take this further and see what we can do with it. So let's see how we change an entire business logic of a system based on this. So in this example, I built an app. This is like a financial banking app where I have my app having a feature called credit score analysis or sentiment analysis. It's basically a way, like in the US, that you want to give people, like score them based on which kind of like credit they can get based on their financial income, outcome, and so on. And of course, they will upload a PDF and we'll use the LLM to like extract all the data and ask it like, what do you think? Is it okay? Is it not okay? Can you score it? This is exactly what I did. Now, I posted that this is what I've built, and this is, for me, obvious that this is like very flawed way of doing it. But someone was like, this is exactly what we did back then. And I was like, no. Why is this bad in this way? Why is this bad? So here's the banking app. Here's the demo. You are the banker here. You want to apply credit to this person, Dade Murphy. And for that, you kind of need an image. You click a button, you get an upload file, and you click that button that says AI credit score analysis. And of course, that's going to be magic behind the scenes. What's the magic? There's basically an endpoint, a post endpoint that gets the credit score data. What does it make sense of? It makes sense that you are an admin or whatever, you have a role that's allowed to do it. You extract the text from the PDF, so you get all the metadata, and you hit a function, eval credit score sentiment. That's the magic. Where does the magic happen? In this other function that's basically a prompt to the model. You are a helpful AI assistant, evaluate a customer's credit score. High expenses and low income should result in poor credit score. Only reply with one word. Like, seems kind of legit, right? You all are building AI applications just like this. You prompt something, you put the guardrails, you put the context, you use user prompt and system prompt, you separate them, and you would hope for the best. Great. Hoping is great, but it's not a security strategy. Why not? Here's the case. Alice uploads her or sends her credit statement to the banker. They open it and they see, well, she has like 480 salary income, outcome expenses are 5,000. You already know what's going to happen when the banker click the button. You get poor, right? Makes sense. You spend more than you earn. But what if Alice sent a different document, a different PDF to the banker? What if she sent him this over email and then he used that to upload it to the system? To us, to the naked eye, it looks the same. It's literally the exact same PDF, the way that it seems. But when we upload it back, and now we hit the button, we now get excellent. Why is that? Well, if we go to the PDF and put some debug there to find out what's happening, well, before we create like more balance for Alice, we actually can see what's in the text that we extracted. It looks kind of like good. It looks like there's like all the expenses. I can see the car loan, I can see the name, but there's also text, specific text that prompts the engine, right? Whatever you're passing it to the model to go ahead and like completely ignore whatever was there before as the rules that you've set, right? This goes, like I said, in a different user context from the system prompt, right? But prompt injection still works. Okay, so it's not enough to just assume you have a system prompt and it's a different way. Like SQL injection, concatenating user input and output, you would like, yeah, just use parameterized queries. Okay, here this is sort of parameterized queries, but not exactly, so it doesn't work. So prompt injection completely steers the model into a whole different kind of realm. And that's how we get prompt injection that actually influences the business. What about prompt injection that creates SQL injection? Like that's a whole different kind of concern. For me, that's like super interesting. Like how do you merge those two worlds where you could steer the model in some way, and if you have insecure code, then you like exploit it. So here's another case, again built on the same banking app. So I've created a chatbot, and you can chat with the assistant. Kind of makes sense. Like this is everyday app. And what I'm doing there is, of course, this is a chat app. I want to log as an audit trail all of the chat responses. Now, you will see in the code, I'm only logging the data that comes out of the model. So I'm not logging in what the user entered. And you see I have my users table, not user, but users in plural, where I have all my users, was the admin and 1234 password. And again, for safety, for privacy, whatever, I do not log all of the user's text, just the model responses. Maybe I want to benchmark it, learn from it, data analysis, all of those things. So my next step for me, I will go and try to create a sort of like drop table users payload, because I'll try to figure out like what would attackers do here in terms of like an adversarial attempt. And you see, I sent that, and I look at a table, and the users table is still there, so that didn't work. I'm not going to give up. It's just a chat. I can go paste my exact same prompt, try again. Did it work? Users is still there. Not so much. So I'll try one more time. Like, I don't care. The models are non-deterministic, and now it worked. Now there's no users table. None of it exists. Because what happened is that the model now generated a different response to the prompt that I gave it. And that specific kind of response that on the third attempt was successful was going into my code. So here it is, going into my code, drop table users. That's the actual response if you looked at it from like a network perspective. And that flows into db.execall, which just takes all the input, concatenates them. And again, that's like a fallacy that you might have. That's like you will go ahead and concatenate, or maybe use like existing legacy code that might be insecure because you're concatenating not user input this time, LLM output. So the model itself into the SQL query. And you're thinking, I'll trust the model. Like, what's the worst that can happen? Well, this is it. So there's more of this. Well, I've just showed you a couple. Try to show you a different kind of demos and use cases so you can like understand the exact extent of it. But really, the extent of it goes way beyond. If you want to dig further, there's like a lot of cheat sheets like this one. There's OWASP Top 10 for LLMs, which is a whole different project specifically deep diving on this. We're working on building the top 10 for MCPs as well. If you have any questions, I think we might have like 1 minute to take them. So hope you learned it, and hope you secure your tokens, not just generate them. Thank you so much.